Welcome to our channel Sankalp Study Success. Today we are going to see about Mathematical and Statistical Foundations, which is the most important subject for CSM students. Here the first topic is greatest common divisors. What is the greatest common divisor? Now when you consider two numbers, the greatest common divisor of those two numbers will become the GCD. Let us take an example so that it can be very clear. Take an example of 2, 6. What are the common divisors of 2? 1, 2 because it is a prime number. What are the common divisors of 6? 1, 2, 3 and 6, correct? So these 1 and 2 are the common divisors for both the numbers. Now the greatest common divisor is 2. So GCD of 2, 6 is 2. So this is the GCD. GCD is also known as greatest common factor. Now how do you denote GCD? When you consider a comma b as two numbers, we are dividing a with b. That means we are finding the divisors of a and divisors of b. So we denote it by a by b. This is the notation of GCD. We generally denote a by b as the notation of GCD. Now coming to the note, which is very important one, when any one of the number is 0, that is a comma 0, or you can also consider 0 comma b. That means any one of these numbers is 0, then GCD will become the number itself. That means let us take an example. Okay? Let us take an example 12, 0. Here one of the number is 0 and the another one is a non-zero integer. So now GCD will become the number itself. If the first number is 0 and the second number is, let us say, 27, then the GCD again will become 27, the number itself, because one of the number is 0 here. Okay. Now coming to the basic properties of integers, here there are few basic properties which are very clear. That is, the first one is commutative law. Here you can see a plus b is equal to b plus a, and similarly with the multiplication, and the same will continue here. Associative law, additive inverse, and identity. The main important thing here we have is well ordering principle. This is the most important thing. What is well ordering principle here? Let us take one set of integers. 7, 9, 20. You can consider the numbers randomly a set of integers. In this set of integers, this is the smallest element, correct? What is the smallest element? In any set of integers, if you have a smallest element, then that set is said to be well ordering set. So that means the set follows well ordering principle. Now, see, we have an example here so that you can see 1, 3 and 7, correct? 1, 3 and 7 consist of a smallest integer, which is 1. So smallest is 1. So this set is said to be a well ordering set. If any set doesn't consist of smallest integer, then you can say that it does not follow well ordering principle. Okay, now coming into divisibility. What is a divisibility? If you take two integers a comma b. Now a is dividing b, or you can also say b is dividing a, as you wish. Now if you are saying a divides b, then it is a by b, correct? When do we say a number is divided by another number? When a number is divided by another number, if you get the remainder as 0, that means what? R is equal to 0. Then you can say that a number is divided by b. See here, we are having in the note we are having a remainder theorem, that is a is equals to bq plus r. This is generally a remainder theorem which we have already learnt in our earlier classes. That is, if see the second point, if r is equal to 0, that means what? When you substitute here r is equals to 0, then you will get A is equals to BQ. When R is 0, it becomes A is equals to BQ. That means A completely divides B, exactly divides B. That means what? A is a multiple of B. We can say that A is a multiple of B, correct? See here, there is an example. Here we consider A is equals to 21 and B is equals to 5. So, 21 is equals to, we know that 4 into 5 is 20. We have a remainder 1. That is what? Here, this 21 is not exactly dividing 5. That means we are not getting the remainder as 0. So, here 21 is not a multiple of 5, but we are just expressing these two numbers as A is equals to BQ plus R. Okay, clear? Now, coming into the most important one, the definition of common divisors. What is exactly? We have discussed what is GCD, correct? The greatest common divisors of two numbers. It is the largest positive number that divides both the integers a and b. Here we have an example, 12 and 18. Let us also consider the same example, 12, 18. Here the divisors of 12 and we have the divisors of 18. But what is the common divisors? 2, 3 and 6 are the common divisors, and the remaining are not the common divisors of both the numbers. So in 2, 3 and 6, the greatest number is 6, correct? In 2, 3 and 6, the greatest number is 6. So 6 is the greatest common divisor of 12 and 18. So we can say that GCD of 12 and 18 is 6. So you got it right. First we will write the divisors of both the numbers. Then you need to compare which is the common and the greatest one. So from the name itself you can understand greatest common divisor, which is 6 in this case. So you can have the clear notes here so that you can understand more better. Now coming to the so let us solve some of the problems. Greatest common divisor of 12 and 14. 12 and 14. So now common divisors of 12 are. What are the common divisors of 12? 1 is the common divisor, 2, it is also divisible by 3, and 4, 6 and 12. These are the common divisors of 12, correct? Now let us write the common divisors of 14. What are the numbers that might divide 14? 1, 2, 2 sevens are 14, correct? 2 sevens are 14, and the next number will be 7 and then 14. Now, what are the common one? 1 is common, 2 is common, and I think there are no common, correct? So only 1 and 2 are the common divisors. Here, among these 1 and 2, 2 is the greatest one. So GCD of 12 and 14 will become 2. So let us see the answer. See here, GCD of 12 and 14 is 2. If you need one more example, we can also take 24 and 32. Here, 24. First we will write the divisors of 24, then we will write the divisors of 32. Now compare these two. What are the numbers that are in common? Let us write here. 1 is in common, 2 is common, 4 is also common, and 8 is common. Are there any common integers which we have left out? No, correct? So the greatest among these 4 is nothing but 8. So 8 is the greatest common divisor of 24 and 32. We got it correct. Now, let us go into the next topic, relatively prime numbers. What is the prime number, first of all? Prime. What is a prime? A number. Let us consider a number A. A number A is said to be prime when it is divisible by 1 and the number itself. It should be divisible only by 2, 1 and the number itself, then the number is said to be a prime number. Now, coming to relatively prime integers. What are relatively prime integers? See here, when GCD of two numbers, that may be a comma b, GCD of two numbers is equals to 1. This is the important one. When GCD of a comma b is equals to 1, then you will say that a and b are relatively co-prime. See here, if GCD of a comma b is equals to 1, then a and b are said to be relatively prime. You can also say it is a co-prime, or you can also say each is said to be prime to other. So, let us see here. If there are more than two numbers, then what is this case? If GCD of there are n numbers, n integers, you can also consider any number of integers. Here we are having n integers. GCD of all the n integers is 1 here. That means all these are relatively prime numbers. Now let us take an example. 9, 13, 85 and 92. Let us solve it here. 9, 13, 85 and 92. These are given. It is most important to write the given data. You will also get few marks for given data, correct? So, you need to find the GCD of 9, 13. We all know 13 is a prime number. So, if 1 is a prime number, then our GCD becomes 1. Now, GCD of 9, 85. We need to find each and every GCD of each and every number. Here, 9 and 85. What are the divisors of 9 and 85? If you write and solve it, you will get the GCD as 1. Now, the GCD of 9 and 92. Again, the GCD of 9 and 92 will become 1, correct? Now, the combinations of 9 has been completed. Now, let us take the combinations of 13 again. 13 is a prime number again. We will get GCD as 1. Then GCD of 13 and 92 will become 1. Now, GCD of 85 and 92, because combinations with 13 has been completed. It is 1. So, for each and every number, you are getting it as the GCD as 1. That means what? GCD of 9, 13, 85 and 92 is 1, correct? So, all these numbers are relatively prime numbers. Relatively prime. They are relatively prime. So, see here, all the GCD of all the numbers is 1. So, they are relatively, pairwise relatively prime. Because we are seeing it as pairwise, correct? So, pairwise relatively prime. Now, you can also solve this one more example, considering the numbers as 6, 10 and 17. If you find out the GCD of, which is very easy, you can also do it, 6, 10 and 17. 17 is a prime number. So, we'll get the GCD as 1. Now, if you find the GCD of 6 and 10, what might the GCD of 6 and 10? Common divisors of 6 are 1, 2, 3 and 6. What are the common divisors of 10? 1, 2, 5 and 10. So we are getting the greatest common divisor as 2. That means it is not 1. GCD of 6 and 10 is 2. So here, for each and every pair, we need to get the GCD as 1. Then only we will say it is as pairwise relatively prime. But here, we got the GCD of 6 and 10 as 2. So, 6, 10 and 17 are not pairwise relatively prime. So, this is the important one. You can check it out. Now, let us go into the next topic, which is linear combination. So, what is linear combination is actually? Let us see here. linear combination. Now we have already found the GCD of two numbers, correct? It is considered GCD of two numbers a comma b. We have already found the GCD. Let us say that GCD of a comma b is equals to small d. Now, whenever you express these two numbers as a linear combination, you can see here linear combination of integers a and b, that is sum of the form alpha a plus beta b, where alpha and beta are the integers. Now see here, alpha a plus beta b is equals to d, which is the GCD. This is the linear combination of any two numbers, which is most important. If we solve a problem, then you will come to know. Let us see here. GCD of 28 and 12. Here we already know what is GCD of 28 and 12, correct? 28. Divisors of 28 are 1, 2, 4, 7, 14 and 28, correct? And the GCD of, and the divisors of 12 are 1, 2, 3, 4, 6 and 12. Now, the common divisors 1, 2 and 4. These are the common divisors. The greatest among them is 4. That means what you will write, GCD of 28, 12 will become 4. Now, we need to express these two numbers as a linear combination. Here the question is, express the GCD of this as a linear combination. So how do we express alpha 28 plus beta 12 is equals to 4, correct? This is our standard form. Now we need to find what is alpha and what is beta. Here it is written, see, 28 alpha plus 12 beta is equals to 4. Now how do we find alpha and beta values? By trial and error method. By using trial and error method, we need to find alpha and beta. See, the answer we need to get 4. That means what? 12 twice is 24, correct? 28 minus 24 will become 4. That means what? If alpha is equals to 1 and beta is equals to minus 2, when you substitute 28 into 1 plus 12 into minus 2 will become 4. Is it correct? Yeah. So these are the values of alpha and beta. See here, alpha is 1, beta is minus 2. So this is the most important question. You can also expect it for 1 mark question. Now, coming to the GCD of n positive integers. What might be the GCD of n positive integers? We have already seen the GCD of two numbers a comma b. How to find the GCD of two numbers? If you have the GCD of n numbers, then how do you find? In the same way, you will consider the divisors of one number. You will also consider the divisors of second, the third. How many numbers do you have? That many numbers. You need to write the divisors and find out the common divisors of all numbers and find the GCD. Now, coming to this linear combination of n positive integers. By solving this example, you will come to know 12, 15, 21. First of all, we need to find the GCD of all these numbers, GCD. What is the GCD? Here we have written the divisors of 12, 15 and 21. See which is the greatest common divisor. One is a divisor which is common, and there is no 2 and 3. 3 we are having, right? 3 is the greatest common divisor. So GCD will become 3. Now you all know how to express the linear combination, that is 12 alpha plus 15 beta plus 21 gamma, which is equals to 3. That is nothing but the GCD, correct? So now we need to find alpha value, beta value and gamma value. We can find it by using trial and error method. By using trial and error method, if alpha is equals to minus 1, beta is equals to 1 and gamma is equals to 0, because here we need to get the answer as 3. To get answer as 3, when you substitute these values, then you will get, then this equation will be satisfied. Am I correct? So now we can express the linear combination as 12 into minus 1 plus 15 into 1 plus 21 into 0, which is equals to 3. So these are the values of alpha, beta and gamma. You can also try all these numbers so that you will get more clear and about GCD.